half a year ago or so, in December, I did a talk about LXD. That's a Linux container thing. And this presentation is sort of like, you can think of it as a continuation of my learning. And in a way, so we'll go easy into the topic, and you know that I'm not a perfect admin, or so only the reasonably useful and easy things are those that I use. If there's something not very convenient, I'm trying not to use that technology at all. It's my mantra. So in December we had a talk, and a little later we had a little, I believe Paul sent email, and there was a thread about Docker, and somebody mentioned like Docker Swarm. And then they said how easy it is to switch between the machines and push new versions of your stuff to the machines. And I'm in a position of actually having a system of microservices. It was all in jails, and for me it was like, oh, that's what I want to do. I want to have an easy way to move things along. So that's how I ended up doing the LXD. As Tim pointed last time, LXD and Docker are a little bit different things. So LXC is like your system, your whole system. It's not virtualized completely, just on the, it runs on the same kernel. But the Docker is supposed to run in one process. That's the point. You can find a way to also add init inside of your container, but it's not what you usually do. It's only for one-offs. And actually, think of a Docker as an init process for the processes that you want to run. So say you have a few processes that do the logic for your application or for your inside of your system. The Docker is an init system that will start them, kill them, move them somewhere else, something like that. But the Docker itself, like the container, is like a very simple thing. And in a way, it's boring. So what's really interesting is that other piece, how you put those Dockers, those big parts of Lego together into the system. And if you think about it, Docker Incorporated has actually done the right thing. They introduced this simple thing, Docker, which isn't particularly useful if you don't have their whatever cluster-like solutions. And I guess Google came out with Kubernetes, open source. But now, as far as I understand, Docker is like providing themselves a clustered way or easy way to use these simple parts, which are the containers, Docker containers. So now Kubernetes, there used to be a joke about how complicated XML is, and I believe that the way to set up Kubernetes in comparison to Docker, it will be like, there will be jokes in this shape of it. So now everything that I looked up was taken from the docs. Docs for Docker are really cool, like really good documentation. The only things which I haven't found in the docs were the quirks, and it's like they're one-offs, and they're very few. But the docs are perfect. The CLI and thing for the domain, they're sort of on one side, and visually they look like on the same side with the composer file, but because the composer file is, and the swarm was sort of brought into Docker a little later, like the company Docker Incorporated bought another company, so you can sort of see it in the documentation. It's still a total disconnect. But docs are perfect, and almost everything which I've done came from the docs. Now, we can talk about Swarm immediately, but I decided to start from the initial point. What we have in this Docker Lego. And the first thing is that we have images, and the images are simple. This is a Docker file in front of you. We can. So this is how it looks. The image usually is created from some initial introductory image. Usually it's this is a simple file. This is for Ubuntu. So there is an image for Ubuntu, and then I say run, do something, do something, do something, do something, and that sort of every one of those steps create layers, new layers in something that will constitute your new image. Jason, I have a question. How to turn on the Wi-Fi? That's the only thing I forgot.
Oh, sorry?
Wi-Fi.
How to turn
Wi-Fi.
Oh, the Wi-Fi?
The Wi-Fi.
Oh, it's just browse for pretty fly for Wi-Fi, and it's secret 555 with the catalyst. It's right on the board behind you.
Okay.
Yeah, behind you.
It's up on the whiteboard on the top right there.
Oh. So I realized that for this demo I need the Wi-Fi.
Change the passwords.
Well, how to do it. People feel comfortable once a year.
Is it capital X?
Yes. Yeah, capital X, yeah. Yeah, that doesn't work. We have another one, but it's not.
On. So this is our file, and let's see what Docker does with it. The way to run this the way to build the image is very simple. Docker, build, and then tons of options. So maybe I'll retrace back to the docs. Docker CLI, there's like Docker has a very nice command line design, similar like to what you have in LXD, and was similar like to what you have in NPM, very standard thing. Docker, then command, then some other options. So it's pretty standard. So let's do this. Sudo Docker. So if we just type Docker images, that's what the images I have on this particular machine. Sudo Docker. Build. So build takes a few options. One is the tag. So whenever we build something we want to name, we'll name it node 10 like this. Note that the column separates your versions of the files. And sometimes people will say that your name node 10, which I just typed, is actually sort of a little repository for all of the versions of the images that you may put it. So that might be sometimes used in the docs or sometimes in commands as the repository, or maybe like in error messages, like what you're talking about. And that's the name of your file. The name of the image is sort of like a repository for all the other versions of your image.
I just want to put a slight correction on that because I forget.
Yeah.
So the part after the tag, the node all the way through to the T and latest, that is, they use the word tag more than one way in more than one places. So
Yes.
that is the tag. That whole string in totality is the tag. And there's a couple of interesting things to realize about that. The beginning and the end parts are not dissimilar from each other.
Yeah.
They're frankly the same type of stuff. They're just a syntactical sugar to say, you could say something over here if you would like to. The other thing is they're not mutable, which means you can go ahead and pull something like that, and tomorrow you might get something else. And so there's another format where you can replace the colon latest with something, and at Shaw sum. That will give you reliably something or fail. So if you want to absolutely know what you're getting, you need to use that format. If you're like, I want something that looks like this, then you can use this format.
Yeah, this latest is usually like if you pull something, it will bring you latest. But whoever has that, whatever, say, CouchDB, for example, CouchDB, when I was pulling the image, I put CouchDB, pull it, and then it pulled the latest. So let's try to see it. You see, this thing does the step by step and sort of creates that layer, and it's all in synchrony in half of how our file went. So there was first update, and then up utilities upgrade, and here I was installing even WinPG because there's no WinPG in the Ubuntu, in a simple Ubuntu. And Paul, when you asked the question like on LXD last time, how do you trust those images? Well, the answer is, let's see, well, the answer is you just don't trust them. What you do is, here's the bigger file from the Postgres. So it starts from a stretch symbol. So it's a little Debian thing, it's called sleeve. And here every little layer, so for example on the first one there's needs some GPGs in it, you know. Then somewhere lower they have the keys to see if the signatures on the stuff which you pull from the Postgres side is correct. So all you have to do is to trust those keys or verify that these keys are correct. So instead of blindly pulling your images, what you can do, you can just go into this repo, whatever the hub for the images on the Docker, and instead of just downloading the image, just click and it pulls you in GitHub usually, and look at this file, just copy and run it yourself, like this. So you don't trust somebody else. You can do it on your machine. All you have to do is that, oh, there's this particular signature, or this particular SHA for what I need from that particular site, from a CouchDB or from a Postgres. So this way you can start your organization, build it up, completely trusting what you can trust, right? Now, let's return. So that was easy, right? So there's again a Steam note, a few things that can be done on the options. This is a same sort of image, but notice how I only added things at the bottom. I only added things at the bottom. The initial ones haven't changed. Let's see. So let's try to run. Let's go Rust. so we talked about the tag. This is the file which I was showing you. There's another thing. At the bottom, I put this little thing, this folder. Basically, it's a folder for the context. So sometimes these images here, which I have, say, for the Rust, it's actually image for the developer. So it's only adding a few tools. Later on my building thing, I add something else, and the context folder here is the place where Docker will pick up the stuff from your local machine which you want to be in the image. So that's anyhow. So let's build this. So notice how the first few lines were skipped. So the first lines which were the same, that were run the same way when we were building the previous file, the first ones, they were simply reused. Docker will reuse a ton of stuff. So when this image will be created, it will say that, for example, it's 300 megabytes. But actually, the first 200 might be coming from another image. They just happen to be the same. In a way, somebody said philosophically that, oh, there's just a few gigabytes of code that will run the whole world. And maybe they are right, because some of these layers are repeated all over again, and you just copy them, you don't have to do them again. But this is also a catch. This is a catch, this is a quirk. If you try to make an image, and if you don't change the lines, yet these lines have to produce something new, you will have to build the image without the caching. Don't forget about this caching, because sometimes people get into a situation where they build an image and it comes up the same as it was before, because the Docker simply reused the cache. So that's one of the things. So it's downloading the installer, because it's a Rust file. It's a funky thing. But anyhow, let's move on. So these are the images. That's the basic thing. This is a static piece. That's the code that's supposed to work, that you're supposed to run. Now, to run that code, Docker has the run command, and there's a tons of options how to run your process, right? This complexity is irreducible. You cannot make the simpler thing than the Docker has done. Why? Say you have an image. That's only one question on it's an answer on what you're going to run. That's the image. Now the second question is, what data should you connect to? Or what network should you connect to the process? All of those questions can be answered in those options, of which there's tons. And somewhere in there you can also say that please run my process so that there's image process inside of the container. So the container is something that you run. So in Docker vocabulary, it's important to get it. The image is something that you create, and the container is something that runs. It may run once, then stop. You can stop it, restart it. You can use the container like restarting things, but you can never have a container that never runs. At least in a regular CVI, you cannot make it. let's do the run, run. So here, do you see the lines? They are high enough. So I'm picking up the command to run image nginx. It will be run in such a way that the port in the process inside of the container 80 will be mapped onto the 80 port on this device. So that's the P for the port, and there's the name for my container. Because if I don't give it a name, it will give some other. Now, before I run this, let me assure you that I don't have an nginx image. Image. So I don't have any nginx image here. For some reason I can't. So So you see, it says unable to find the image, and then I'm trying to pull it. So this is the usability thing. That's why the Docker is so powerful, so cool, so nice. It will try to help you in these little ways. But it's also a little quirk. What if you have a few things you want to turn them on? You're turning them on, and you, like in 10 seconds, you're checking your browser. Is it up? And it may not be up yet, because other tools might be doing the pulling of the images in the background. It's only this run command that will do the pulling of the images before starting your process. So that's sort of another thing to watch out, but it's very easy. So it should be local host, and that's the nginx which we had, and now we can use the ps command on the Docker for processes, and it shows what processes you've got. At the same time, the PSA for all images is very useful, especially when we'll go into the swarm later on, and when you're trying to do some investigation, your dead processes will be hiding under the PSA flag. The PS shows only active processes. So anyhow, we have that process. Let's close it. So Docker stop, and my nginx 1. Yeah, we stop the Docker, and if we try to reload it, it's dead. And then we can start the Docker. Sorry, start my container. So here I already created a container by way of starting it once, and then container exists. So let's check again. R. So the running one process is cool when you need it. Also, like LXD, when you have a running container, you can do Docker exec execution of some command inside of that process. when the container is not running, you cannot execute anything. This might be useful, like for example, you have a database and you want to run a little script while on the database. Yeah, but besides that, it's not very practical. And the practicality is that we have stuff like labs. And the lab has two things. It has a switch on off and it has a function. It works or not. That's all that I want to know about the lab. Like Linux, Apache, my whatever stack. All useful stuff comes in stacks. So this is the Lego parts for the Docker, and the Docker says that the stack is a few services. So think of it, your Apache, your MySQL database, and say something else. 3 microservices, 3 elements to the system. Now the service itself runs, it may run one or a few containers. But in the language of the Docker swap, of the Docker, they will call it that it runs task. Task has a container. Basically what it does, we say, please run this stack. And the Docker realizes that we need 2 of those containers. It creates the tasks to run them, but it doesn't guarantee, like, the container may not have started yet, you know. So in the documentation, you have to understand that the tasks sort of exist inside of the service. It's not the container, and the container inside of the task runs only once, and then it gets killed. And if you want to start it again, you can do it, but only manually. Why it is important? Let's say you have this plan, and let's say attacker got into this thing, and it tries to fuzz it, right? And the process crashes. So instead of restarting thing that may have some bad stuff with the attacker, you restart again from the image, from as if you were fresh. But it is fresh only up to the point if this process was never connected to, say, a volume where it was storing some information. So again, as I said, you have an image that starts the process. Then there are these questions: what data this process saves? Where does it save? How it is connected to the broader internet, or how it is connected to other things. Those are irreducible details, which I think the best done in the Docker, because this is the 74-line file with three services, and we have just one file that answers many questions. Some of the questions are nice defaults, but some of them are not. So let's look at this swarm file. Basically, it's not as it's called a compose file. Basically, you will hear the words Docker compose. Basically, you compose a few running services together, so that's why the compose. Now, this is an interesting composition. This is swampy. It's a system to look at all of the nodes in your swarm, see how they run, and show you nice graphics about the Docker. It consists of a service which runs, but whatever, the swarm peak, it's swarm peak. Now then, as usual, that thing has a DP in the coach, right? And then we have another service which is actually placed on every machine. That's how this thing functions. So I have this file. I really don't. I say Docker deploy this, and it does it. That's it. That's the magic. So let's demo it first. Docker deploy. Okay. Sudo docker deploy. We deploy that file swarm-pit YAML. And we'll pull the swarm-pit. I forgot the stack, because we're deploying the stack, right? So we say Docker stack deploy. And that's basically a setup. So the next time somebody comes to you and say, hey, I have something in the Docker. What you want them to give you is the Docker Compose. Nothing else. Don't even settle for anything less than that. Because usually things require a few services, and they have to be in the Docker Compose file. Now, let's do this. So if we just stop it, it says what we can do with this. Let's remove the swarm peak. Well, let's first show that we have that stack up. Notice that it has 3 services, and notice it says orchestrator swarm. I never seen in my short career anything other than swarm, but hey. So let's remove it. Boom, it's gone. Now what I want to do is to talk about actually the swarm part. Now the swarm command has, let's do the swarm leave, and it won't let me leave if I don't post it for some reason. Don't know. So let's do the and do the deploy again. So if somebody gives you a YAML file, compose file, the Docker complains. I can start only if I do it in the swarm. So I'll put it this to you. The very useful part that Docker has is this composition of the processes that go together. The swarm part, the fact that it can run not on one but on several machines, is a cherry on top. So this talk could have been called some other way, not the swarm, but because it's connected, it's brought up in this product this way. Well, that's what it is. So let's add the swarm init. Now notice when we run on the machine the initialization, it says that yes, we are now created a swarm, and here's the string you can give another machine to attach to become a part of this swarm. Now the machines can work either as workers or as managers. Now the Docker has this little thing, node, and it basically displaying what are the nodes in the swarm. Right now we have only one machine, that's my, and it's, the manager status is sleeping. Now, if you notice, when it comes to the swarm, you can look at the stuff, you can, when you talk about the node, when you have several machines, let's say you want to restart one of the machines. So in there, like these are details of multi-machine, right, of the distributed system. In there you can say, please update that node and make it availability to be equal to drain. So it will drain all of its tasks, so it will close all of its services. And when it will be draining the tasks in one node, the swarm, for example, it knows that that service needs 5 tasks. So it will recreate, start the processes on other machines. So these are details that are nicely described in the documentation. It's almost perfect. Yeah. Now let's restart the stack deploy swarm, right? Now notice that we have deployed 3 services in one network. And the swarm, so this compose file has all of the details about how the process is run. So let's go first quickly. So one service, SwarmPit, I assume it's the main one. It has, this is the flags for its environmental variables for the process, setting them nicely. We give here to this process a volume. But in this case, in the case of a Docker, this is a volume called Docker socket. And that's basically when you do all of those commands that I showed you, it's actually a Docker command talking to the socket. If I don't put sudo, the error message says that I don't have a right to open this Docker socket. That's all. Now, if you don't want to use sudo, you can attach yourself to the group Docker for simplicity. That's another thing. So, the volumes. These volumes can be sockets. They can be just Docker volumes. I haven't used them. And below in here we have a mount, a binding mount. So this folder actually exists on my machine. I had to create it. Inside of var for SwarmPit, I did a sudo make dir, and that's on the host, and this is what is found inside of this CouchDB process. Now, the name of this process is DB. Up will find DB, the DNS name, on this network, thanks to the Docker. That's what the Docker does. It creates these networks inside. They have a resolution for the things. So this DNS also provides the load balancing. So let's say this is not let's say it's a funky DB, of which there can be 2 instances.
Cassandra?
Maybe. So if this thing says Cassandra, the first time, the DNS will give it one service location, and then it will give another service location.
Another good option is like, just with reverse proxies, you can spin up a bunch of front ends. Let's say you're receiving a lot of HTTP requests on the front end.
Yeah.
and you're trying to load balance it across a bunch of front end nodes with DNS.
That's for the front end
Yeah.
stuff, yeah. But this is for internal networks.
Sure.
So now, as I said, there's like details of running stuff are irreducible. You cannot reduce them. They still have to be there. So after the networks, we have a little deploy. On my stuff, which I make, in the testing, I generate my compose file for the testing in the stack. And in the stack, I have deploy, which says that just one instance is enough, that's it. And in production, of course, I have a different deploy. And this deploys, for example, from Swarm Pit, the guys that make a Swarm Pit, and they have put some limits on that Swarm Pit server. And that actually needs a lot of memory. And if we'll go we look at the Docker PS. We don't see a lot of stuff. For some reason, it's not here. See, not everything is working. So that's what I told you. There's quirks when you use the Swarm. You roar up the stack, but not everything is up. See, for some reason that thing has exited. And you see, that's the command inside of the thing. It uses Java, so that's why it needs a huge amount of memory. But what I want to point you is that the name of each of these things are actually the name of your stack, then the name of your service. Then you see that number one thing, for some
First
reason,
replica.
and then that unique thing. That other unique thing is probably related somehow to tasks, but you see that task has run, something failed, it's exited.
And that'll be the app that failed, not Docker itself.
Yes, it's an app that failed for some reason. I don't know why. It honestly ran, but now I have an opportunity to show you how it fails. Yeah, but you see, the agent, the other thing is running. Yeah, the agent is running. Okay, whatever. Yeah.
In previous slide here,
Yeah.
the CPU 0.5 below
Yeah,
0.25.
so we go into docs for the compose file, and there they state clearly that CPU means exactly one logical CPU. So it doesn't mean like half of the thing.
Sure, maybe this isn't your question, but it seems like limits would be, you would want that to be lower than reservations. It seems odd that reservation for like, I don't know.
No.
It's the other way around.
No,
Really?
Upper limit
no.
and
You
reservation.
reserve the minimum, but you don't allow it to go too far.
I see.
And strangely, with these limits, I was doing my calculation for my production.
Sorry.
3 stacks together, and I did the calculation. I put the deploy limits in, I put them on, and some of them are not coming up. Just exactly the same way this failed, but it was showing like there's not enough resources. You have to play with those calculations. But again, these are details which are sort of irreducible. Yep, Paul?
So is it supposed to be Docker Swarm's job to keep things alive? Or is it just trying to run these things as a group? Like
Yeah.
something fails and it dies, is it supposed to bring it back up? Is that its job, or is it
Yes,
doing something else?
yes. So here in deploy, there will be, it's either section with subsection or specifically saying that what to do when it fails. Restart, would do nothing. Like in this case, as far as I understand, it's a standard thing, it just does nothing. Okay. In the deploy, you have a section, for example, I have a section replicas, I put 3, and then what to do when to auto start them. Then, for example, there's another option for an update. How do you update your stuff? Do you first turn off the old service and turn on the new one? Or you turn on the new one and remove the old one later on? So those are actually options, and those are actually relevant details when you create your stuff or use somebody else's stuff. But as far as I understand, like, I tried to open the Kubernetes documentation, and I'm like, no, I left university a long time ago. I read comic books now, documentation maybe, and the Docker way is the only like reasonable thing. Like, yeah. So the other thing I wanted to notice here, there is the placement, the constraints. They are very useful for the databases, because you see the database actually connects to the volume, and that volume physically has to sit somewhere. So it's important where in the swarm your process is. So the placement helps you, and the placement is done using the constraints. So in this particular constraint, there's a label on the node, which I said that it's free and web system swarm with system processes. I put them and say true, and the machine, only the machine with this label will be able to run this. The Docker has this simplicity thing. So basically, all we need to know is this line. We have to remember the task runs once, and that container will run only once. That's it. So that's why if the container saves anything, you have to attach the volume. And it can be volume like Docker volume. They are still localized to a machine. Maybe there's a way to move them, but I don't know. So that's why I'm sticking right now for just binding to the machine. It's easier, because my bind is my ZFS folder.
So Docker Swarm, it takes advantage of some of the underlying capabilities of Docker, which has a plugin architecture for its storage. So I'm pretty sure I remember seeing this ZFS plugin, but there are various different ones that kind of knit together and route storage. So, for example, you can say, I need this thing by name. It's a type foo, and its name is such, and it will send it to a node, and that node will actually activate, connect that storage, and then start the service. And so you just need to look into
Is that freely available? Or is it
there's
some-
dozens of things. There are free ones and there are paid ones. I've been wanting to implement this for years, but of course my boss always wants to pay me something else, so I never did it. But yeah, there's stuff out there. Have fun. NFS can be used. Somewhere I saw a talk with like a magic string you can put it to just NFS mount things automatically when a service starts. Have you done this, Mel?
No, I'm just tuning
You
it
want
out.
this?
But it's something that, if you're talking about storage plugins.
Yeah,
Yeah.
storage plugins. I think NFS might be built in. Sure, could be wrong, but
Yeah.
so yeah, there's solutions to that. If you can't bring your service to your storage, there are solutions to bring
What
your storage
about
to your service.
what about the overlay file system? I haven't actually delved into Swarm yet, and the one thing that I've been kind of allergic to is having to figure out where to store things. It's something that I want to do,
Yeah.
but it's not something that I have done. Same reason why I haven't delved into K8s. But go ahead. Is there what about it? Like,
Do the placement.
overlay?
Do the placement and use the swarm, and
Yeah,
Don't
overlay
worry.
is, and you're talking about like a cross node file system?
Yeah, so like if you have like a multi-host swarm, where does the overlay system decide to stick the volumes?
What overlay system you
Well,
use?
isn't
An
it like an-
overlay is what Docker uses to manage its
Right.
layers.
So there's no like, you have to
Overlays
have it
in
in
the
the
network.
Yeah, yeah. Okay, fair enough. Fair
There's
enough.
overlay network. There's
So-
stuff.
But not overlay file system.
Yeah. So that's the data. So we talked about the binding or mounting and the data volumes for, folders on a container. But with the swarm, it turns out there's this detail about configuring all of your processes. And if they happen to be on multiple machines, sending and pushing configurations is a very useful thing that Swarm does for you. And there are two things called one configs, another called secrets. Secrets is actually configs, they just encrypt it. They encrypt it and they only push to the needed places and that's all. So, very useful.
I could be wrong, so correct me. My understanding is secrets are never persistent to disk. So if you lose power to your cluster, all the secrets go away. They're never actually written.
I haven't tried to unpower my cluster.
Yeah. But that's the safety, is
but-
they're only kept in memory.
But there was actually saying that they are in encrypted form.
Well, they're transmitted over the network using the encryption, so things get offered from the master the secrets they need as they ask, as they need them,
My,
and no more.
my understanding is actually that they actually stored somewhere on the management nodes, but with the encrypted form. That's my understanding from the documentation which I read. Again, look at it's the same docs. It's with the secret and configs. I didn't venture outside of the docs. So those two. Yeah. So with that secrets, this is perfect. Like the secrets are perfect. I have three databases. They don't have to be on the same machine. They're on the stacks, and the secrets pushes the necessary passwords to the microservices that use one database but don't use another one, and this is perfect. And your secret and maybe the config will be simply mounted something inside of the container, so you access it as a file. Very simple. I mean, very usable. I'm sure it's not simple the way it's created inside. Now, this last thing, and maybe the most important, is the networks. So, think of the Docker networks in two ways. There's local network, and there's an overlay network. That word you've heard mentioned today, overlay. So, the local means local to my machine. So, remember our service. Here are the ports. That's the binding. And the target is what's inside of the container. The published side is what gets published outside. And in this particular case, it says mode host. Host means this thing, although it runs on the swarm, it will publish the 888 on the host on which that service is present. Okay, so if you have two machines and this server runs only on one machine, if it's serving locally on the host, only here it's available. Now contrast that to the overlays network. So the beauty of the overlays network is the following. I have 5 machines, and there's a service that publishes say port 80, for example, and there's like 4 or 3 service instances of the service that do the publishing. Now, if you do requests onto any of those 5 machines, that ingress traffic will be routed to the correct service. More so, that routing will also be done in a load balancing way. Now, when I heard that, I immediately loved the Docker, and that's how I started to play with it, and this is how we got this presentation in the first place. So basically, the overlay networks, this magic is cool. Now, the other cool part is that this network on the line 16, it's defined inside of the swap. And it's accessible only to the services of the swap. That's it. Don't need to any firewall. More so, imagine that you have 5 services and only 2 are talking to the database and nobody else is. Then we create a network for the database and only have those 2 services sitting on the network. More so, if those are 2 different services, you want to create a point-to-point network to the database. Why? Let's say your service A is busted and the hacker is inside. All it can do is talk to the database. It cannot do the lateral movement. So instead of doing the firewalling, which is removes the ability for an attacker to do lateral movement on your network, we create the network in such a way that allows only those connections that are allowed. Unfortunately, Docker Swarm is not perfect in this case, because in the perfect world, I would say this, that on this network, this service is only a client and is not hosting any ports. That would be the perfect world. We're not there yet, but this is a great step in the right direction. Basically, part of my work when I was doing the microservices on FreeBSD was setting firewalling, trying to remove the ability for the lateral movement of the attacker. This just removes it immediately. You can screw it up by just having one network, but now, well, since they're easy to create, like, you just put a different name, and at the end, there's like this little section where you say what the network is. And by the way, some of these sections here are written in the longer form. There is a shorter form for the compose file. And, but the YAML format, it's all messy. The 2 concepts that are necessary for the networks, which are usable, are those when you try to create a local bridge. So basically on the machine you can create a bridge to which you can connect your container. Your container, when you create it right away, it's by default connected to a default bridge. And that default bridge has default settings. And the default settings has 2 interesting flags. One is called interprocessor communication, and they said no on that bridge, because it's usually, and the other one, it says masquerade. One word, masquerade, means that I can, when do we do masquerade? When we want to aggress, when we want to get out. So, that's the quirk of the defaults. All of your containers with the default bridge, they can aggress. So, say you have a microservice that got busted. What do you want? First thing is not allow attacker to call home, right? So with the local bridges on the Docker daemon, there's a flag or a thing which can be placed into that JSON file, that will make that bridge not do masquerading by default. That's an easy fix. Now, the more complex fix is the overlay networks. Unfortunately, the overlay, when you are on the swarm, you are connected to the thing called gateway bridge, and that's and there's no way to set it up so you never connected to it. And the only way to around it is when you initiate, when you start your service, and then you unplug. I think we can try to do this. So sudo network network OS. So you see, there's a bridge, there's a host, there's that ingress magic through which all the connections can get into different things. There's some node, and there's this swarm feed net, sort of internal network. And by the way, it can be done in such a way that you can attach the container, like your system, like your administrative container to it. So there might be an option as an attachable. So here's another concept. Your network can be attachable or not attachable. But here's that Docker gateway bridge. And let's do the disconnect. So we have here's our swarm feed, the only agent that is left. And network disconnect. And then what it says? It says, please give me network and the container. So that's our work. And this is our container. And this thing doesn't like it. The swarm doesn't like when you detach from the from this gateway bridge, and that gateway bridge actually hiding very tough inside. And yeah, but that's the only way to ensure that your running container is not aggressive. It will continue working like everything else will work. So basically, from time to time, you probably need a service that looks what's connected to the gateway bridge and disconnected. And okay, for the sake of time, I think we'll just do it. So when I saw the networks, I was sold completely. You know, that's the best world, the best thing since the sliced bread. So we talked about the network quirks, that everything is possible, and that it's only the problem with the Docker gateway bridge, which you have to disconnect them dynamically offline. The other thing is this is a distributed system, and in that distributed system, remember we said here's the service, it has a name app, and there's another service has a name DB, and those names actually have to be in DNS. And if your process wants at the start to exactly have that name existing, then it might be a trouble. So it takes time for DNS to start this.
When you have you used the depends clause in Compose? And if so, does that deal with that issue or not?
supposed to do that, but it's no longer present in the newer version which comes with this one.
Oh dear, okay.
Yes, I might be misled, but something like that was in the documentation. I have to look it up, but
Look it up.
yeah.
I'm here.
But my feeling that, and everybody who were trying to have, so basically what you think is like, okay, so I have an ingress, it's for example, it's hub proxy, and that hub proxy is doing the TLS for me, right? And then it uses a backend, some other microservice, or a few of them, right? And those microservices, each of them are replicated, but they go by the name. And that name is, for example, say app. And when hub proxy starts, it finds no app and it dies really fast. So the hub proxy and Nginx, they have that strategy to check fast and fail fast for their backends if they're in a DNS name form. So, and since we want to keep the names to make it simple, we don't want to deal with IPs and stuff. The only other way is to keep your hub proxy outside and point them by IP onto any of your machine in your swarm, and this is how we can do the proxy. Now there's traffic or traffic, whatever. That traffic service is supposed to do the DNS. A, it's slower than hub proxy, and B, it's the service. Yeah, I'll be done. That this service takes in the input, and at the same time it looks inside of the Docker socket. So when you go inside of the Docker socket, it's exactly the same as if you have root privileges on the host. So for this security reason, the traffic might be not as nice. Because if somebody hacks the traffic, they have entry into the Docker socket equivalent to the root access. Not nice. That's it.
You're right. It is not available. Version 3.
Sorry for keeping you long. But
What other values can you do? At that YAML file you have host and the manager, like what other values can you set there?
Let's do it.
So is that the actual mutual documentation between Compose and Swarm? It's literally 100% the
One
same
second.
now?
So we can be respectful of everybody's time.
Yeah.
I would say, why don't we, I didn't announce, or I didn't repeat the usual, but we usually go for dinner afterwards, and I'm guessing you're coming?
Yes.
So if you have questions,
Perfect.
come, buy a beer, and ask questions.
Well, that question is for the video, and that's why I opened the video right there. The dogs are perfect. And here's the town of Start and that's for the those are details. They're irreducible. You can't mix them. I yield my time.
Thank you very much. Always, containerization stuff, always very interesting. All right, so we're gonna break for maybe 5 quick minutes. We'll get the laptop switched over.